Hello, everyone who's either live participating with the second GoToMeeting of Monday, August 24th, 2015, or you're watching the recording on YouTube. So either way, welcome to this meeting. This is Math 171, Section 61, Western Piedmont's online section of pre-calculus algebra for this semester. And this morning's meeting, which is already posted up on YouTube, and I've posted that as your second announcement. It's in Moodle. You can see the link, how to get to that. This morning's meeting was all about just the course itself. We didn't talk about math per se. We talked about the course and what the course is about, how it works, and what's required of everybody. Now this afternoon, we finally get to actually talk about math here together. So we're going to basically talk about the first section in the first chapter, section 1.1. And of course, that's your first homework assignment that's due tomorrow evening. It's due Tuesday evening, August 25th at 11:59 p.m. That is actually the time that all your online assignments are due. They're always due. The online assignments are always due at 11:59 p.m. So this first one is due tomorrow evening, and I see there's a number of you that's already been working on it. That's great. But I hope this session this afternoon will be helpful to everybody. So the first thing I want to do is call up from my own iPad here using Air Server. This is a program called EduCreations, and it allows me to actually use our screen, now use my iPad as if it was like a miniature whiteboard. And that's nice that I can do this with you. The drawback is my finger is the drawing device, and trying to write, as you can see with my finger, looks a little bit primitive, I guess I could say, but if you can follow and understand, then we'll make progress here together. So again, there's your title right there, Math 171, Section 1.1, Graphs of Equations. And what this is about is simply understanding what we mean by the graph of an equation. How do we generate the graph of an equation, either manually with pencil and paper or with a graphing device like a graphing calculator, or as we're going to look at also an online graphing calculator called Desmos. We're going to look at all this together, and just variations on that of different types of equations. How do we graph them, and understanding some of the basics of their graphs. So one of the simplest types of graphs, and before I even start talking about the math, once again, as I said in the meeting this morning, it is really incumbent upon each of you to read the sections in the textbook before you start the homework assignments. We're obviously in section 1.1 out of the textbook now. That's in your textbook. It starts on page 75, and the actual text before you get to the exercises at the end goes through page 80, so that's a total of 6 pages. And read through that as much as possible. Maybe skim some repetitive parts that you're already familiar with, but at least read through it. You're going to find that many of the questions in the homework directly refer back to definitions, terms, examples, formulas, techniques that are presented in the text of each section. So please don't shortchange yourself and just try to jump and do the homework without even looking at the textbook first. Okay, so let's take a good basic example problem and talk about some terminology with graphing. What do we even mean when we use the term equation? An equation is essentially a relationship between two quantities, and we typically call the quantities variables like x and y. So typically an equation will have two variables and sometimes more. On occasion, it'll only have one, but that's sort of an exception. And if we have an equation with two variables, say x and y, then when we say a solution point of that equation, we're talking about a specific x-coordinate and y-coordinate that makes that when we enter those values for x and y into the equation, it makes it true. So let's start and talk about this for a minute here. If we had, for instance, the equation y equals 4x plus 6, and we were wanting to find some solution points for that. You may recall that an equation such as this is going to graph as a perfectly straight line. And you may even recall some specifics. That number in front of x is the slope, 4 is the slope, and 6 is the y-intercept. But actually, that's not the content of this section right now, but it's useful information. But the graph of that equation, if we were to graph it either by hand or with a graphing calculator, is going to be a straight line. So what do we mean by a solution point? We mean a point that is on the graph of that line that if you enter the x-coordinate of the point and the y-coordinate of the point as the values for x and y, substitute those into the equation, it'll make a true statement. So for instance, if I were to consider the point (110), and is that a solution point or not of that equation? And you'll recall what I just did was write out an ordered pair inside that parentheses, 1, 10. The order in that term ordered pair means that there is an order to those two numbers, and the first number is understood to be x and the second number is understood to be y. And so if I input 1 for x and y for 10, let's see what happens. Okay. It's not what there we go. Okay, so if I plug in, say, 10 for y, then 10 equals 4 times the x value, 1, plus 6. And we're wondering if this is true, so I'm going to put in question mark over the equal sign to indicate that we're testing this to see if it's true. And one of the key points of doing this kind of work, that didn't work, trying to move the screen up. There it goes. One of the key points of working with equations like this and doing algebraic steps with the numbers in any equation is to always go by the order of operations. I'm confident everybody has been learning order of operations since maybe 5th or 6th grade. And the good thing is they haven't changed. They're still the same. Remember, you always do your multiplying and dividing before you do any adding and subtracting and such as that. Anything in parentheses first, those kinds of rules. So we're going to do our 4 times the 1 first and then add the 6. So continuing on here, (10) equals question mark 4 plus 6. And now we can add the 4 and the 6 finally. And yes, 10 equals 10. I'm going to put a check mark over the equal sign to indicate that we finally resolved the question. It's no longer a question. Yes. If we input 1 for x and 10 for y into the equation y equals 4x plus 6, it ends up making a true statement that 10 equals 10. And thereby, we can say that the point 110, that yes, it is a solution point. And this means if we were to graph this equation, that the point 110 would be on the graph of the equation y equals 4x plus 6. We just demonstrated it using algebra. But I'm going to now introduce a program to you. It may be introducing, it may be new to you, or it may be something you're already quite familiar with, but either way, this is a free online graphing calculator. It's a very excellent program. We use it quite much in the math department here at Western Piedmont. Our students are using it more and more. So I'm going to shrink this down now. It's oftentimes easier to use and more efficient than your classic Texas Instruments graphing calculators. So what I'm going to do is call up this program now. And how do you get to this program? Well, very simply, it's just desmos.com. That's the website, desmos.com. I do not know how they came up with the name, but that is the name. Desmos.com, and this is their introductory home web page right here. And whenever we use this, then you need to first click on Launch Calculator. And here's the program coming up right there. You can come up with a screen and entry area over here on the left, and numbers and symbols and all sorts of things down at the bottom that are very useful. And so let's graph this equation right here. I'm going to enter it in, y equals 4x plus 6. Instantly, Desmos shows us the equation right here. And you can see it has a y-intercept up here at 6. And let me pull this down a little bit. When I point at that point right there on the y-intercept, 0, 6, very nicely, Desmos highlights it for us and confirms that it is the point 0, 6. And regarding the x-intercept, I can point at that and it says it's negative 1.50. So since both those points are points on the line, then in the terminology that we're expressing and explaining this afternoon, those are two solution points of the equation. So 0, 6 is a solution point because you plug in 0 for x and 6 for y. It makes a true statement with our given equation, y equals 4x plus 6. If you plug in negative 1.5 for x and 0 for y, yes, that comes true too, because negative 1/2 times 4 is negative 6. Negative 6 plus 6 is 0. So negative 1/2, 0 is also a solution point for this equation. Now what we're wanting to find out is, what about the point 110? And that does not highlight simply from pointing at it. Desmos doesn't do that for any random point. But we can look at this graph here that's right in front of us now. And for x equals 1, going up to meet the line, we see that when x equals 1, the line is exactly at y equals 10. And I'm going to change the scale now by rotating the little turning wheel on the top of my mouse. I'm going to change this out farther so we can see this a little bit better. Now, if you can barely see at the bottom, the x equals 1 line, 1 point is still indicated at the bottom there. It's right here. So with that being x equals 1, you can see even more precisely that yes, when x equals 1, y equals 10. So yes, the point 110 is a solution point on the graph of this equation. So we've demonstrated this now algebraically as well as graphically. Okay, now I'm going to go back to the Air Server program on the iPad again. Trying to move this up. Well, there it goes. There it goes. Okay. All right. Okay, let's look at another equation together. And let's figure out how to actually graph it manually, like pencil and paper. So let's take the equation 2x minus y equals 4. And I trust most everyone will recall that if you wanted to plug this equation into your graphing calculator, a Texas Instruments TI-83 or TI-84, as most people use, you would first have to do some algebra on this equation and solve the equation for y, so to speak. Get the y by itself on the left side, everything else on the right. And oftentimes that's useful even if you're going to graph it by hand. So let's do that. Let's do this algebra here together. 2x minus y equals 4. If I subtract 2x from both sides, I will get that negative y equals negative 2x plus 4. A little bit rough on the plus sign there, but that's what it is. And now if we simply multiply that entire equation by negative 1, change the sign of every term on both sides of the equation, we'll end up with y equals 2x minus 4. And let's start off by graphing this manually. And this is probably going to look familiar from years ago when maybe your first pre-algebra class or first algebra class, you made a table of x and y values. So if we do that now together, let's make this table of values for x and for y equals 2x minus 4. Let's do about 6 different ordered pairs here. So for instance, if x equals negative 1, and we plug in negative 1 for x, so 2 times negative 1 minus 4, well 2 times negative 1 is negative 2, negative 2 minus 4 is negative 6. I'm doing the xy numbers now in red. And what about when x is 0? Well, 2 times 0 is 0, and 0 minus 4 is just negative 4. And when x is 1, 2 times 1 is 2. 2 take away 4 is negative 2. When x is 2, 2 times 2 is 4. 4 minus 4 is 0. When x is 3, 2 times 3 is 6, and 6 minus 4 is 2. And finally, when x is 4, 2 times 4 is 8, and 8 minus 4 is 4. So what we've created are actually 6 ordered pairs. They're not in the standard parentheses with the comma in the middle, but they're in a vertical format, 6 ordered pairs, specifically negative 1, 6, 0, negative 4, 1, negative 2, 2, 0, 3, 2, and 4, 4. And now if we want to graph this, and we can make our axes. And let's see here. a little bit rough, but hopefully it'll be understandable here. All right, now when we start plotting these points, -1, -6, so that's in between 0 and -2, horizontally speaking, and down to -6. So I'm going to plot these points in blue. The first one is pretty much right there. And then 0, -4, this is what we call the y-intercept of this line. And then 1, -2, and 2, 0, x equals 2 and y equals 0, x equals 3 and y equals 2, x equals 4 and y equals 4. And now we can connect those dots, and I'm afraid my finger is going to be a little messy on this. Let's see if I can do this here. There we go. That is a rough sketch, emphasis on rough. So there is our line. Y equals 2x minus 4. And so we created that line manually, the old-fashioned way, creating some points, starting with some arbitrary x values that we choose, determining the corresponding y value for each of those x values. Thereby, we created 6 ordered pairs of x and y coordinates. We created a coordinate plane, Cartesian coordinate plane as it's officially called, with x as the horizontal axis and y as the vertical axis. And we plotted those 6 points in that coordinate plane and then connected the 6 points, drawing the line. And I'm going to finally end this up by putting some, now what? Okay, let's see. Something, it just changed to another page here, I believe. I'm not sure. Let's see. Yeah, there we go. And put arrowhead at the other end of the line. So our line is graphed now, officially y equals 2x minus 4. Now, you're going to have homework problems where you're asked to identify whether or not a particular xy point is a solution point of an equation, sort of as we did above there with our first example. You're going to have problems like that. And then you're going to have problems where you're simply given an equation and you have to find some solution points, and you can do that by just entering an x value, for instance, and solving for y. So on this one we just did, if you had y equals 2x minus 4 and you were given that x equals 7, how much does y have to be so that x and y together will be a solution point? Well, you simply plug in 7 for x and you get that y is equal to 2 times 7 minus 4, that's 14 minus 4, so y equals 10. So that means the solution point then is 7, 10. So anytime you need a solution point for an equation, you can just plug in a random value for x, as long as that value of x makes sense with that equation, and then solve it for y, and those two numbers, then the x coordinate and the y coordinate, will give you a solution point for that equation. Okay. So let me take us to one other place now. I'm going to take us into WebAssign for our text. And I am now in the student view of WebAssign for our course. This is essentially what it should look like when you open up WebAssign yourself, as most of you have already done. I'm going to click on My eBooks and click on that right there. Quantitatively, sorry, no, that is not our book. Okay, hold on here, let's see. Why is it showing that? My eBooks. Okay, yeah, I got to go down, that's why. That's for another course. Here's our book right here. Pre-calculus, real mathematics, real people, alternate edition. Here we go. This is what it's supposed to look like. Okay. I'm going to show you how easy it is to find things in the text. You can click on, for instance, chapter 1 over here. Then all the sections open up like that. And we're in section 1.1, so I'm going to click on that, graphs of equations. And it immediately takes you right to that page 75 of your textbook where section 1.1 begins. So online you have a perfect reproduction of the manual hard copy textbook. And we've just been talking about determining solution points for graphs and all. And down here at the bottom of this page, I just want to show you this box. This could be helpful to you. Sketching the graph of an equation by point plotting. If possible, rewrite the equation so that one of the variables is isolated on one side of the equation. Make a table of values showing several solution points. We just did that for y equals 2x minus 4. Plot these points on a rectangular coordinate system, just like we just did, and then connect the points, depending on what it is, either with a straight line or with a curve, because there may not be a straight line. You may have a graph of a square root function, or it might be a parabola with a quadratic like y equals x squared. So whichever it is, a smooth curve or a straight line. And they give you several examples and illustrations of this in the text. I'm just showing you this. Excuse me. And they do give you a brief definition of the term intercept here on page 76. The points at which a graph touches or crosses an axis, either the x-axis or the y-axis, are called the intercepts of the graph. Of course, if it crosses a y-axis, that's a y-intercept. If it crosses the x-axis, that is an x-intercept. And then they go on to using a graphing utility. So we just graphed that with Desmos. But you can, of course, also do this with a Texas Instruments 83, TI-83, or a TI-84. You can graph things like that yourself. One thing the text actually emphasizes quite a bit, I'm not emphasizing that much with you, but the text emphasizes very much setting the window, how you define the window of your graph, and that can be very key in certain problems, but it may or may not be depending on the problem. So I trust everybody here has used a TI-83 or 84 before, but I'm going to give you a helpful tip on that too. If you have questions about using the Texas Instruments 83 or 84, what I do when I have a question, I'm confronted with something I want to do and I can't remember or I've never learned how to do, I will typically go to a search engine like Google and say TI-83 graphing a square root function or something, and it will you'll have websites come up and it'll just remind you just how to do that. Whatever it is you might need to do, finding the y-intercepts on a graph, or finding the zeros of a function, or the such as that we'll be talking about in another chapter. But I just want to offer that to you, that you can literally use a search engine to discover how to use your calculator when you need help with that. Anyway, I trust everybody's going to recall, I think we mentioned this a few minutes ago, but when you use a graphing utility, almost always you have to rewrite the equation first so that y is all by itself on the left side. That can involve some algebra, sometimes fairly much, and sometimes not so much. So once you get it to where it's just y by itself on the left side and everything else, the x terms, the constants and all, are on the right, then you enter that equation in the graphing utility, and then you determine a viewing window that shows all the important features of the graph, and finally graph the equation. Now, the standard default with Texas Instruments, the TI-83 and TI-84 graphing calculators that most people use, the standard default window is x from -10 to 10 and y from -10 to 10. And sometimes that's fine, that's perfectly good, and other times the key element of the graph you might need to look at is not in that window, and you have to manually change your window, change what the minimum x or the maximum x or the minimum y or the maximum y, such as that. Now I'm going to give you a tip that could be helpful too. I'm going to bring up the Desmos graphing calculator once again, and I want to show you something on here that with the Desmos graphing calculator we do not have to do the algebra and isolate the y. This is nice, very nice feature of Desmos that is not true about Texas Instruments graphing calculators. You may recall, I'll remind you here, the equation we started with that we graphed using the table of xy values, the actual equation we started with was 2x minus y equals 4. And nicely, Desmos is perfectly satisfied with us entering equations like that. We do not have to solve for y. You say, well, where's this second equation? Well, I'm going to now delete the first equation we already graphed, and you're going to see the second one was really right on top of it. It's just a different color. It's bluish color instead of reddish. So I'm going to eliminate the red and get this. Let me get this scale back here. There's our line again. And I'm just looking at it. Yeah, that's right. That's the same line we had before. So this is nice. You can do this with Desmos. And also, I'm going to continue this on. Other sorts of equations that are more involved than just a nice straight line works so simply with Desmos also. In your homework, you're going to have problems that have square roots in them, have x squared, even x to the third, and you need to know how to graph these problems, how to graph these equations using your graphing calculator or using Desmos, however you want to do it, or you can manually do it by hand, and you're going to have to identify these graphs and sometimes even create them in WebAssign. I'm going to go over that in just a minute, how you can create some rather simple graphs. But for instance, if we wanted to graph a quadratic here in Desmos, it's as simple as this. If we wanted to graph the quadratic y equals 2x, use the caret sign for the exponent, 2x squared minus 3. There it is, simple as that. There's the parabola for y equals 2x squared minus 3. It's already graphed, and as you can see, the 3 green dots right here show the the 2 x-intercepts and the 1 y-intercept. The y-intercept at 0, -3. If you have a more complicated equation, like y equals 2x to the third, I hit the right arrow key to get out of that exponent mode and back down to here, minus 2x, caret key again to get it up there, and squared, and the right arrow key to get back down, minus 2x minus 1. Now we have another one on there. We have a cubic equation now. You can see how the cubic equation comes up from the lower left, suddenly drops back down again, and then goes up again, literally forever and ever. So rather complicated equations can be graphed quite, should I say, quite simply using Desmos. What about if it's got a square root in it? Well, if we had one like this, like y equals 2 times the square root of x. How can we get a square root in there? Well, if you look down below here at these symbols at the bottom, that's actually a square root symbol. It looks like a check mark, but it's a square root symbol. So I'm going to just click on that symbol. It inputs it into my box up here in the upper left. And now I just insert an x inside there. And now we have the graph of y equals 2 times the square root of x. So let's get rid of these first 3 now and just leave that one. And I'm going to zoom in a little bit on this. So there's the graph of the equation y equals 2 times the square root of x. Let's make a couple observations about this graph that actually are significant. Please notice the graph starts right at the origin at 0, 0, and it goes then up to the right, literally forever and ever and ever, gradually banking downward, so to speak, it decreases its slope upwards to the right forever and ever and ever. It never levels off, but it gets closer and closer to being level. So the point is, it starts just at 0, 0. You cannot enter a negative value for x into this equation, and I trust you recall, we cannot take the square root of a negative number and output a real number. It actually outputs what we call a complex number, which we will study in a later chapter in this course, but not a real number, so you can't graph it on a real coordinate plane. So the smallest real number that has a square root is 0. The square root of 0, of course, being 0. So the one solution point, in fact, the very solution point where the graph starts, is the solution point 0, 0. X equals 0 and y equals 0, the origin. And then if you wanted to find another solution point, you could input, to keep it sort of nice, you could input values of x that are perfect squares, that have a nice square root that's a whole number. So for instance, if we entered x equals 4, well, 2 times the square root of 4, 2 times the square root of 4, the square root of 4 is just 2, so 2 times 2 is 4. So when x equals 4, y should equal 4, and sure enough, when x equals 4, you can see right here on the graph, it is true. Y equals 4 also, so the point 4, 4 is also a solution point on this graph. But notice the graph does not go straight from 0, 0 to 4, 4. It arcs up, it curves up. Square root function is never going to give you a straight line. If we tried, for instance, 9 for x, because 9 has a nice square root of 3, then 2 times the square root of 9 would be 2 times 3, which would be 6. So when x is 9, we should discover that y is 6, and sure enough it is. Since the square root of 9 is 3, 2 times the square root of 9 is 6, and so that's right on the graph of y equals 2 times the square root of x, right here, the point 9, 6. So I do hope you find using the Desmos program helpful to you. Excuse me. I also want to show you how to use WebAssign to do a simple graph. So now I'm going to switch back to WebAssign, and I'm going to open up your very first homework assignment right here together with you. It's the section 1.1 homework that's due tomorrow evening, Tuesday evening. And let's go down to problem number 6. In problem number 6, they give you, in this version, you all are going to have different numbers in your problems, essentially the same problems but with different numbers. For instance, in this one here it says complete the table. 21x plus 7y equals 42, and you may be able to see on your screen that the 21, the 7, and the 42 are all in red, which means that each of you students is going to have those 3 numbers in red as different numbers for each of you. So here's one version of this problem with 21x plus 7y equals 42. Well, if we want to graph this, we're going to want to first solve it we want to find a couple of solution points. I'm going to show you how we can do this. To find a couple solution points. One easy way to find a couple solution points, class, oftentimes is to just let x be 0 and y be 0. And so if y is 0, 7 times 0 is 0, so 21x equals 42. And then solving for x with 21x equaling 42, divide both sides by 21. The number in front of x, and you end up with x equals 2. So one solution point is that when y is 0, x is 2. So here we can put that in here for 2. Y is 0. So the solution point is 2, 0. And if we let x be 0, this is the other easy one, typically, not always, but oftentimes easy to do. If we let x be 0, 21 times 0 is also 0, so it's just flat out 7y equals 42. Well, with 7y equals 42, to solve for y, you simply divide both sides by the number in front of y, which is 7. And dividing 42 by 7 gives us 6. So when x is 0, y equals 6, and we've got a solution point 0, 6. Now, it's actually a fact, class, that if you wish to graph a line, and this is the equation of a straight line, it has both x and y without any powers or square roots in the equation. To graph a straight line, you only need 2 points. And let's look and see how you can graph this using the graphing utility that WebAssign gives you. You have just a few problems where you actually have to enter the graphs. And like the instructions here says, select an object from the Tools menu to the left. You can get the arrowhead or a line or a circle, a parabola, or a point, or even no solution. And then enter coordinates in object properties below, way down here, or just use the mouse to move the line or the point or whatever you want to wherever you want to go to. And let's do that now. Let's start with our points since we've got 2 points that we know. So I'm clicking on the point icon right here, and I'm going to put the first point at 0, 6. And you see what's happening now. Since I've clicked on that dot, now as I move the cursor around the coordinate plane that WebAssign supplies to us, I can move this up to 0, 6, and now I'm going to click. We've got a point on 0, 6. And now let's put the second point in at 2, 0. So I go back and click on the dot again and move the point now to x equals 2, y equals 0, right there. And I click again. All right, now that's nice. We got 2 points, but we have to create a line. So to create a line now, I can come back and click on my first point and then move off of that point. Oh, I'm sorry. I did this a while ago and it was working. All right, hold on. No, yeah, click on the line first. Click on line first, that's right. Now I'm going to start at this point and drag. Notice how wherever I go, it starts with that point, a line through that point, and I want to, of course, have it go through this point down here. So there it is, going through that. Get this right here, come on. There. Now I click again. And now I'm going to have to click one more time anywhere in the open space out here to finalize the line. And you can see down below, down here, we've got our points in there. 0.1, 0, 6, 0.2, 2, 0. Yes, that's what we want. So now I'm going to click out here in the empty space, and you see the black line fills in through the 2 points. And now, once you do that, your graph is finished, and you're prepared to submit your answers. So let's, we only did part of this, okay, but let's just check our answer. Now I'm going to go ahead and click on Submit Answer for this problem number 6. Okay, now here's what happens. We only did part of the work. We did not fill in 3 of the 5 solution points, so we only got the green check marks, which WebAssign gives to you when you get it correct, on the 2 of the 5 that we did, the 0620, plus we got a green arrow down here on the graph for correct. So if you were doing this at home by yourself, I trust you would put in all 5 of the solution points, of course, before you submit your answer. If you get all green check marks, you're fine. You can move on. But if you miss one, then you can do that problem again, start over with that problem again, and you have 5 attempts actually on each problem. Now sometimes what WebAssign is going to do in your homework problems, they're going to show you 4 different graphs. For instance, on number 8, it says match the equation with its graph. Y equals 6 times the square root of x, and by the way, you're going to have, each of you is going to have a different number there, perhaps 6 or some other number, and it shows you 4 graphs here. And when you, how do you do this? Obviously, you don't have to enter a graph into WebAssign. They have already put forth to you 4 complete finished graphs, and all you have to do, this is like multiple choice, multiple graphs. You just pick the one that is correct, and whichever one you think it is, then you select that circle for that graph. Like for right here, if you think it's this first one, you'd click on that circle, and then it fills in with a black dot, and then you'd click Submit Answer. If you think it's that one, you'd click, if you think it's this graph, you'd click that circle and then Submit Answer. If you believe it's this one, you would click on that one, and etc. So here's a little preview of some of the problems in the 1.1 homework. For instance, here's another one. Number 10, sketch the graph of the equation y equals x squared minus 7. And they give you 4 completed graphs. Once again, it's simply multiple choice. So you use your own graphing utility, like your Texas Instruments graphing calculator or Desmos or whatever you prefer. Get your graph and then compare it with these 4 and identify which is the correct one and mark it and submit your answer. And that's the way many of these problems are, as you're seeing right here. Here's y equals the square root of 1 minus x. So you'd have to carefully enter that in either to Desmos or your graphing calculator. Or if you want to do it by hand, that's fine too. It's not the easiest way, but you can, of course. It's one of these 4. And I'm going to tell you, when they give you 4 graphs like this, I've never seen the answer be none of the above. So it is one of those 4. So if you perhaps have graphed one of these things and it does not look like any of those 4, then you probably made a mistake. You're going to want to graph it again. And here's one, number 16. It's y equals 5 over x. Now, 5 will be different for many of you, but it's some number over x. And they give you the 4 graphs to choose from, and then they also say approximate any x or y intercepts of the graph. And if there's not an x-intercept or not a y-intercept at all, then write in the words, actually write in the words in capital letters, no solution. I'm just scanning down through here, and that's the very last problem right there. On this very last one, they ask you to use the zoom and trace features of your graphing utility. Now, you can do either a zoom and trace with your Texas Instruments graphing calculators, or even in Desmos, you can easily change the scale in Desmos. In fact, much easier in Desmos than you can with Texas Instruments. And answer this question based on the numbers that they give you there. So that is the last problem of our homework. And once again, I really hope that you can make good use of the Desmos graphing calculator this semester. If you haven't used it before, I encourage you and welcome you to experiment with it and try it out. I think you're going to like it if you use it. If you have used it before, that's great. You're already familiar with it. They also have helps and all with Desmos. If I just let's see. Yeah. There's okay, now where's this help? All right, there is a help. Yeah, up here with the question mark, that's the help. Up here in the upper right, help with the question mark. So that's our lesson on section 1.1, your very first assignment in WebAssign, your first homework assignment, which again is due Tuesday evening, August 25th. That's tomorrow evening from my vantage point right now. This is Monday afternoon, approaching 4 o'clock. Due at 11:59 Tuesday evening, August 25th. And I will we're about to end this GoToMeeting, and then I'm going to take the process. Takes about an hour, but I'm going to save and convert this video so it can be posted up into YouTube. And once it is, then I'll give you a link for that also, like I've already posted into Moodle under the announcements there. I've already posted the link for the the morning GoToMeeting session, and everybody can now watch that on YouTube. So I'll post this one up too. Like I said, it'll probably take about an hour or so to process, and then I'll get it up there for you. And I hope everybody has a good evening. And one other reminder to you quickly, I'm just thinking of before we sign off, is please don't forget the mandatory attendance quiz. It has to be done by Wednesday evening. Your first online homework and web assignment is due tomorrow night, Tuesday, August 25th at 11:59 p.m. And your second web homework assignment, the section 1.2 homework, is going to be due Thursday night. We will talk about that in our next GoToMeeting on Wednesday morning at 11 o'clock, and I'll put an announcement in Moodle about that and tell you how to get to that, how to join that meeting. That will be 11 o'clock Wednesday morning. Is going to be our next GoToMeeting, and in that, the intention of that meeting is to talk about the next section in the text, the 1.2 section, for which you have a homework due Thursday night, August 27th at 11:59. But in between, you have a very important date. The mandatory attendance quiz in Moodle, which is a very simple little 5-question quiz, has to be done by everybody by Wednesday night, August 26th. That's the day after tomorrow, from this being Monday afternoon. Wednesday, August 26th at 11:59. You have to do the mandatory attendance quiz or you get dropped from the course. That's pretty serious. So, excuse me here. Most of you have already done that, I'm glad to say. So just for those who still haven't done it, please don't put that off any longer. Go ahead and get that done. And I do hope everybody has a good rest of the day. And as always, if I can help you with anything, please send me an email. I have literally been in meetings of one sort or another all day this day, so I am just about now to attend to my email. Anything you've sent me today, I'm just about to start replying to. So have a good rest of the day, and I'll see you at the next one.